I'm Charlie Whitney. I'm a project executive at Turner Construction Company. We're sitting here today in the 6th floor library of the northwest corner building. We're here today because behind me is one of the most significant features of the project, and that is our trusses. These are the structural trusses that really hold up the building. This is actually a 126-foot long truss. It spans from the south corner to the core of the building, and these really defined our whole project. Some of the challenges associated with building this building were the fact that we're right on the corner of 120th Street and Broadway, very, very busy intersection. We were adjacent to two occupied lab buildings. We actually tied into both of those buildings. And then the third, and this actually became probably the single greatest driver for the design of the building, was the fact that we built over another building. We actually cocooned around it and went up and over. There's 3 trusses supporting the whole building, designed to carry 8 floors of structure. Each truss is supported by 2 columns. The heaviest truss is in the center. That weighs over 300 tons. So one of the most interesting elements of the project was figuring out how we were actually going to build the trusses, because we didn't have a model to go off of. So we had to invent kind of a new process to put the trusses in place. We worked on the problem for almost a year. We looked at building the trusses on the sidewalk and maybe using a 2 or 3 crane operation. Things were too heavy to lift in place with a helicopter. We sat down as a team and we figured out that maybe the way to do this would be to establish a platform over the sidewalk, 80 feet up in the air. We would build the trusses at elevation over the sidewalk, and then when they were fully rigid, slide them into place. We had a very competent design engineer who worked for the structural steel erector. We had a peer review done by the design engineer, Dan Brodkin at Arup. And then we also went out and found a real specialist up in northern Canada, and his life is designing long span structures. So we had 3 sets of eyes looking at this from a structural standpoint. We were positive this was going to work. When it came time to move the trusses, we assembled 2 railroad tracks, one at the north end and one at the south end of the structure. And on top of them, we laid down a stainless steel track. We put Teflon pads on the bottom of each truss. We used an industrial grade soap on the stainless steel, and then we actually used hydraulic jacks to push the trusses across the railroad tracks into their final resting place on the columns. And we were able to move the first truss 85 feet in just a little over a day. The second truss moved out 65 feet. The last truss was about a 15-foot push, and we were able to do that in a couple of hours. At that point, we really had it down. Behind me, you can see the trusses. The top of these trusses forms the tabletop upon which the rest of the building was built. The 4th floor library below us is actually suspended from the bottom of this truss. The architect was so taken by the design of the trusses, they ultimately became a major design feature in the building. The exterior wall is basically a reflection of the diagonals of the trusses, and even where you have open glass, the louvers are actually installed on a diagonal parallel to the angle of the structural steel. You know, every project has 1 or 2 challenges. This building had a slew of them. There were logistical challenges, figuring out how to build the structure, making it affordable. You know, we have a Pritzker Prize winning architect who came up with a beautiful design. And if you take all of that and you wrap one final piece, it's a functioning laboratory. Laboratories are very complicated from a system standpoint, and everything has to work. Everything is movable and flexible. A scientist can decide he wants to do a new experiment this afternoon, and he can be rearranging equipment tomorrow without the help of a builder. Part of the program from day one was to build a very beautiful building. It was also to build a very sustainable building, the type of place where people want to go to work, and the type of place where people want to go to do their research. A LEED Silver goal was established early on. We thought it was a kind of an aggressive goal. You don't have a lot of LEED Silver laboratories. Laboratories tend to be very high consumers of energy. You have a lot of outside air requirements. You're constantly heating and cooling the air. You're not able to recirculate a lot of the air and take advantage of some of the inherent efficiencies with that. So everybody really focused on where we thought we could get the most bang for our buck. We had a very, very efficient recycling program in the job, and we were able to recycle over 85% of our construction waste, for example. And we ended up with a LEED Gold certification instead of a LEED Silver. It was a very pleasant surprise. The building is an engineering marvel, but we spent so much time talking about the structure in this building and the architecture, we really lose sight. To me, was probably the best part of the whole experience was the team we got to work with. The architects were fantastic. Columbia was fantastic. The structural engineers and the mechanical engineer, they were just, it was a dream to work with. Couldn't have asked for a better group of people to work with.